Hi everyone, welcome back to my channel. Today we are going to solve the lead code problem of the day. So today problem statement is maximum level sum of a binary tree. And the problem range is medium, but it is a easy level problem. They mentioned it as a medium. So jumping to the problem statement, given the root of the binary tree, the level of the root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes at level x is maximal. See, return the smallest level x such that the number of all values of nodes at that level is maximal. Here what they are asking is, they are given one binary tree which contain the root and also the children. They are asking to calculate the sum of the elements at the level wise and return the least level which has the maximum value. Okay. Simply it is nothing but a level order traversal. We have different types of traversals in the trees: pre-order traversal, post-order traversal, and level order traversal. Okay, it is based upon the level order traversal. What we want to do here means we need to traverse the binary tree linearly in the sense level by level, and then calculate the sum of the level elements and find the maximum sum at which level it is happening and return the number of that level. How you can return the number of that level means this is first level, this is the second level, this is the third level, and so on. That's it. Simple it is. So one more thing you should notice in the question is return the smallest level x such that the sum of all values of nodes at level x is maximal. Why they have given this statement means there might be few edge cases which have the same sum at two levels. Let's assume here we have 7 0, and here also let's assume we have 7 and 0. So the sum is same at both level 2 and level 3. The sum at level 2 is 7, the sum at level 3 is 7. Then which level you should return as an answer? Definitely it is level 2, because they are asking the return the smallest level x such that the sum of all values of nodes at level x is maximal. That's the hidden edge case behind this statement. So you should be careful while reading the problem statement and break it down into the pieces so that you will be thoroughly clear on the problem statement. Okay. So now let's go into the breakdown of the problem statement. How you should you will perform the level order traversal of a binary tree. Okay. To traverse the binary tree, first of all we will take one queue data structure and store the first element, the root element in the queue data structure. Okay, and then check whether the root element have child nodes, either it is left or right. Check whether it has the child nodes. If it have the child nodes, then store that elements to in the queue and pop the root element from the queue and add it in the list. Okay, so one level we traverse and added that level in the listed data structure, list of listed data structure, because the elements inside the list we are going to store is list type. So it is a nested list data structure. Similarly, second list also we store in that nested list data structure. And finally, you can calculate the sum of the lists we stored in a list and return the maximum level. I mean, maximum level is nothing but the iteration. I value will be the maximum level which has the maximum sum. Okay, let's say this is a brute force solution. Optimal solution also is there. Without storing the elements, while performing the calculation, we can return the maximum sum element. You will see both the brute force and the optimal solution. Okay, this is the brute force solution. In this solution, we declared one maximum sum which is initialized to the integer.min value, which is our final answer. This variable is going to be our return answer, and level is equal to 1 and answer is equal to 1. Okay, so we declared one queue on where we can store our root elements. From there onwards, we calculate the left and right elements. And this is the nested list data structure where we store the list of the list of the levels. Absolutely, obviously, the level is in the form of the list. So we declare the nested list data structure. Okay. So firstly, we are adding the root element in the queue, and in the while operation, we are checking whether queue is not empty and calculating the size of the queue. Okay. So we are declaring one sublist which we going to add it in the nested list, nothing but the wrap list. So take one for loop and iterate up to the length of the queue and check whether the root element or the element in the queue have left or right. If it have the left element or the right element, add those elements also in the queue. And finally, you can add that root element. I mean, the queue element which you are checking the left and right element, left and right children's. Add that root element in the sublist and transfer the sublist to the wrapped list. So one level you got traversed. Again, the while loop continues. Not while not equal to q dot is empty. It is not equal because we added the left and right elements here. So obviously the queue length will increase and queue is not empty. So the while loop will continue to iterate until all the elements in the queue get exhausted. But before that, you will be traverse all levels of the binary tree. After storing all the levels in a nested list data structure, you need to calculate the sum of all the lists which is stored in the list. Okay, so for that we are initializing one nested for loop and calculating the sum of each list. The list which have the maximum sum will be the answer, but we are not supposed to return the maximum sum. We are supposed to return the level of the tree which has the maximum sum. So for that, we declared one more variable which keeps on tracking the answer level. Okay. So for every iteration, the level also increases. So obviously, whenever we receive the maximum sum, at that point we assign that minimum level to the answer level and return that answer level as a final answer statement. So this is the brute force approach. Uh, it will work, but won't that much efficient one. We'll see the optimized version also. First of all, let's see how the brute force works. It works fine. Passing the test cases. Submit on submission also it will work fine, but the percentage it beats of other solution is less. It beats only 5.43%, which is very less because here we are using 1, 2. So almost we are using space complexity and time complexity is more in this brute force solution. So obviously it performs under performance. Okay. So for that we will shift to the a bit optimized solution. This is the optimized solution. So this is the optimized solution. Here we won't store the level elements in the nested list. Instead of storing them, directly we can calculate the sum at the while loop itself, inside the while loop. Okay, and then return the maximum sum and level itself. So we are reducing traversal of the nested list. So time complexity reduces. A big O of n square time will be reduced here, and it will be big O of n probably the time complexity. Okay. So everything is same here except level sum. We declare the level sum variable inside the while loop, and then we are calculating the sum of each level inside the for loop itself. Instead of storing them in the nested loop and again traversing that nested list and calculating the maximum, we are directly performing the sum in this for loop itself, and then checking whether the level sum is maximum than the existing sum. If it is maximum, then updating the maximum level and returning the maximum level. Okay, this is the from video 1 onwards I am saying Optimized solution is nothing but you have to reduce the number of iterations and you have to save the as much as possible space complexity. You need to reduce the space complexity and the time complexity. That's the optimized solution. Nothing more than that. So we will run and see how much percentage the solution beats than other coders. Yeah, well, let's submit it again. Yes, it beats 93% of other solutions. Means we are above than 93 percentage of the solutions. 93.82 percentage of the solution. Okay, this is very easy problem statement only. No need to bother much on that. Just you need to know the traversals of the trees. How to traverse the tree element, binary tree element, binary trees, pre-order, post-order, and in-order, level order. That's it. If you know how to traverse, how to add element, how to delete element, how to append element, how to find element. That's it. Major problems depend upon this minute basics traversals. If you know that, you can able to solve any question by breaking down into the parts. Okay. Thank you.